Okay, so today we're going to learn how to factor four-nomials. And it's actually going to be easier than factoring our trinomials that we did yesterday. So the nice part about factoring four-nomials, again, and I'm calling this a four-nomial because I have 1, 2, 3, 4 terms, is the fact that they come in pairs, so you can kind of split it right down the middle. So that's what I'm going to do right off the bat, is I'm going to split this thing right down the middle. And I'm just going to look at this side and this side one at a time. And when I look at my right hand or my left hand side and I try to factor this thing, I can see that what I can do is I can pull out a 2x because both these numbers are divisible by 2 and both these terms have an x. So I'm pulling out a 2x. That would leave me with 2x plus 5. Now I'm going to factor this other side. And when I factor this other side, I'm going to pull out a 4 and be left with 2x plus 5. Now you should notice a couple things. The first thing that you should notice is that this is the same as this. So when you notice that that's the same, that's a very, very good sign. That means that is one of our binomials, and we are going to actually put that binomial together. So we kind of pulled these binomials together. Now I'm going to get a second binomial by what's left over. As you can see, we had a 2x, and we get a positive 4. So that thing is going to come together, and that's going to be 2x plus 4. And this would end up being my answer of the four nomials. Because what we did was we factored one side, then we factored the other side. After factoring both sides, we pulled the like terms together, and then we pulled the leftovers and put them together too. Okay, we're going to try one more example of this. Okay, so this is my second four-nomial example. And when I have this, again, the first thing I'm going to do is I'm going to break it in half. Once I break it in half, I'm going to factor both sides. When I factor this side on the left, I'm going to notice that, well, 3 and 7 don't have any factors, but I do have an x. So I'm going to pull out an x and put this as 3x plus 7. Then I'm going to try to factor this right-hand side. When we factor this right-hand side, we can pull out a 2, because 6 and 14 are divisible by 2, and I'd have 3x plus 7. Again, what we should notice is that this is the same as this, so I will actually pull those things together and get 3x plus 7. Then we'll take what's left over and pool that together and get x plus 2. And again, we've just factored that four-nomial. So again, it's really nice to factor four-nomials because you just break them into the two sides, and then after you break them into the two sides, you factor them. Okay. And we're going to see in a second how that is going to help us. Okay, so let's say we've been given this problem. And here's why this problem is really, really tough right off the bat. It's because I have 3 terms, and none of the terms are divisible by anything besides 1. Like if you try to think what's going to divide 6, 5, like nothing. And what we can't do is we can't just divide everything by 6 because that gives us a decimal middle number, and that's not good. So essentially, we're not really helped by anything here. So we're going to change this problem. It is a 3-nomial, but we'd like it to become a 4-nomial, so we'd like to get a 4th term. Here's how we're going to find the 4th term. we are going to take the first number. Whoops. We're going to take the first number. We're going to times it by the last number and see what we get. So when we do this, we get 6 times -6, which will give us a -36. We are then going to think of things that multiply together to make -36, but then we'll add together to give us 5. Okay, so we're going to think for a second. The numbers that you hopefully thought of, which will take you a little bit to churn through, but the numbers you hopefully will eventually think of should be 9 and -4. Because 9 times -4 will give you -36, but then add together to give you -5. We're then going to rewrite this problem. And I'm going to rewrite this as 6n squared plus 9n minus 4n minus 6. Now I'm going to stop for a second because that probably went really, really quickly, and you might go, well, why is he doing all that and why can he do all that? So the first thing that I did when I times those things together is kind of just how you figure out all the different factors that things could be. And you shouldn't really think it's odd to have 4 terms from here when we're trying to find 2 terms. Because if you stop and think about different things, is like 2 binomials always multiply together to give you 4 different things. I'm going to show you at the end how this all kind of works out together. But now that we have a 4-nomial, that's good for us because we can do the trick that we just learned. So we're going to split this thing in half. We're going to factor this side, which when I factor this, I will factor out a 3n and get 2n plus 3. I'm going to factor this side now. And this time I'm going to factor out a -2 because both things have a negative sign. And I'm going to get 2n plus 3. And again, we have the nice situation where you have these things that are the same. And so you get 2n plus 3. And you have these things which are left over. So you get 3n minus 2. And now we have this thing factored. Okay. Let's do one more example of this because it goes very, very quickly. Okay, so again, in this example, we can see that we have 3 terms. And again, we don't like these 3 terms because this number, and this number isn't divisible by anything, so I can't pull anything out. So we're going to have to go back to our trick, where we take this first number and this last number, and we multiplied them together. So 4 times 4 will give me 16. I'm then going to think of things that will multiply together to give me 16, but add together to give me -17. The 2 numbers that you should think of should be -16 and -1, because -16 times -1 will give me +16, and -16 plus -1 will give me -17. I'm now going to rewrite my problem. Okay. After I've rewritten this, let's split this thing in half. And let's factor. So this one, I can factor out a 4n. I'll be left with n minus 4. And in this side, I can factor out a -1. So, now that I have that factored, I have 2 terms that are same, which is good again. So I'm going to have n minus 4. and then I take the leftovers, which is this right here. And this would be my final answer. This trick will work every single time, and the more you try it, it will get better, and it will probably start making more sense. Essentially what we're doing when we do this trick is we are trying, I'm going to show this, and I said I'd show it at the very end, but like when you have this here and you when you have this here and you FOIL it, you always should get 4 terms. What we do, though, is we normally simplify these two and add them together. Now, when you factor, that's not actually that helpful to have that. So we're kind of undoing that step. So if you kind of think about like going from here to here to here, or this first step to this next step to this next step, we kind of want to go backwards. So we start here. The easiest next step is to actually get into the 4-nomial, and then the best last step is to factor it. So we kind of try to go in reverse. That's why breaking it into the 4-nomial is better than leaving it in that 3-nomial. Try some of these problems, and if you get stuck, please ask questions. Thank you.